today's agenda. If you go ahead and all you guys in the crowd with your cameras, if you want to scan this will just take you to a link tree. The next couple slides will have the same QR code. So yeah, anytime, just go there. It has a link to these slides and all the resources that you're going to need for the hackathon this week. Cool. So today's agenda, I'm going to go over hackathon bounties, going to do a little bit of an intro to Near, go over chain abstraction, what that means, what it is, also Near and AI, and go over a little bit of hackathon ideas to get you guys started. Then, of course, we're going to end up with dev resources and make sure that you guys are well equipped for success moving forward in your project. So yeah, first off, hackathon bounties that are going on this weekend. We got $10,000 in prizes to give out. 6,000 of it is going to be towards chain abstraction, and 4,000 of it is going to be some way in which you're going to combine Near with artificial intelligence. So yeah, good luck. Hope you guys, submit some awesome projects, and looking forward to seeing them. So what is Near? For those of you that don't know or haven't heard of us, in 2017, it started out as an AI development platform. They wanted to do a bunch of payouts to people helping out with this initiative through Ethereum, and at the time, it was a little bit difficult to build on. So they decided to make a quick pause for 6 months and do a layer 1 blockchain. Yeah, it's been a little bit longer than 6 months to make that a reality. But the idea was, hey, we need to make this easy to use. We want to make it scalable. We want to make it fast, secure, and also eco-friendly, and being proof of stake. So 2020, we spent 2018 and 2019 working on mainnet, and we launched it. We actually, created a proof of stake blockchain, certified carbon neutral with South Pole. Sharded by design, actually down to every account can be its own shard in like a future scalable roadmap. Right now we're about a second blockchain, just a little bit over, like 1.3 seconds. We're cheap, 0.01 cent per transaction on average. And yeah, over the last 4 years, we've had 100% uptime, which is pretty awesome. 4 years and counting. We just celebrated our 4-year anniversary this October, and have almost 1 billion transactions that have been processed on the blockchain. We've sustained about a 14 million transaction per day spikes with some of the top apps in the ecosystem being on our platform. So, chain abstraction, what is this about? Well, it really starts kind of in the beginning, before we started talking about chain abstraction, with the account model. And with the account model on Near, there's basically like 2 different types of accounts that you can have. The first one is probably what you guys are all familiar with coming from Ethereum, are implicit accounts. We use a curve of 25519, 64 characters, and that would be like basically your public key would be your account, an implicit account. No need to fund that. This is an example. And we do have named accounts. These are kind of what sets us apart from being like how we baked it into our protocol to begin with. So each account, is more human readable. You can have Alice.near, Bob.near, Josh.near, whatever, you want. And if it's, as long as it's a .near account. It's also a useful way to organize sub-accounts. So you can have, say, like application, .ls.near, or a DAO at my project.near, and you can keep going further and further. So like each one of these accounts can have sub-accounts or can create sub-accounts. And the Near contract actually is one contract that all the other accounts are a sub-contract or a sub-account from. So all accounts can operate as smart contracts. And that's because all accounts are smart contracts. Every single account on a platform is inherently a smart contract. It just may or may not have code loaded into it, and depending on you as a developer, what you're going to be doing. So yeah, it's pretty awesome. All accounts are shards. All accounts are smart contracts. It's pretty crazy stuff. But what I really like about our platform, and I think it really is unique, are access keys. We have 2 types of access keys. Ones that people are more familiar with, which is called full access keys. Standard public-private key gives you full control over the account. Send funds, do whatever you want, call contracts, create accounts, add and remove keys, etc. The other style that we have are called limited access keys. And these keys, they can only sign contracts calling a specific contract, or you can make it multiple contracts. You basically can like kind of scope your key and give it permissions based on what you want that key to do. And it cannot manage funds, it can't create sub-accounts, and it can't delete accounts. So it's very limited in what it can do, but it is meant to be shared. And people might think keys are meant to be shared. This is a little scary for me. But yeah, you can create a key, share them with applications, and then have them sign transactions for you on your behalf. This is a funny meme I saw a while ago. Yeah, basically this person, every time they want to shoot a player, they have to log in with MetaMask. Okay, signed a transaction, crap. Okay, crap. Now I need to log in again. And yeah, it's a little bit over the top for sure. But with limited access keys, you can create a key, give it to the application or the game that you're playing, and then it will constantly create these transactions behind the scenes and won't have to redirect you to wallet every time. We have a few of these examples where like a near place where you can draw pixels on the actual canvas, and every pixel you draw is a transaction, but you don't have to sit there and deal with this of constantly being redirected. It's just signing these transactions for you. And you can trust that they're not going to be financial transactions. So yeah, limited access keys can only call specific methods on a contract, but you can have contracts do everything an account can. So if you wanted to give someone an access key that calls a method on a contract, you could actually write in your smart contract a certain method that could do, something a full access to an account could. So kind of opens up your mind a little bit of like what the potential is and what you can accomplish. So like what if you create a method that actually transfers fungible tokens or NFTs? You can easily drop assets to your users. What if you create a method that creates new accounts, allow people to easily create their own accounts? So it's kind of just giving you a little bit of idea of like how you can use access keys on our platform. Another area in chain abstraction would be meta-transactions. I'm sure a lot of you guys have heard about meta-transactions. On our platform, we have a built-in system to wrap transactions and delegate covering their fees. So basically, if like say Anna.near wants to create a transaction and they want to execute it, they would wrap it with this delegate action message. They would sign it off-chain and then send it to a relayer. And then the relayer is going to take that, attach tokens to it, and send it to the network on their behalf. But yeah, the network executes it just as it were Anna.near's transaction. So developers can pay for transactions and delegate them for others, so that way their users don't have to worry about crypto onboarding or anything like that, and just do transactions on their behalf, which is pretty cool. Chain abstraction in chain signatures. Excuse me. This is something I'm really stoked about. It's really interesting. We're having a lot of fun playing around with it, and I'm really excited about the potential that we have with chain signatures. Basically, what chain signatures are is it allows one near account, a single near account, that can pretty much control almost infinite amount of accounts across many chains. And how is that possible? Well, first, you'll have your one account, and then it's going to take that account and it'll derive like a unique address, a unique address for whichever chain that you're trying to send a transaction or transact on. Then you create a payload, whatever the transaction or payload or action that you want to have signed. So you take your account, you get an address, you construct your transaction or payload, then you're going to call what's called an MPC contract, multi-party computation contract. That's not the service itself, it's just the contract that's going to call the service. And then the MPC contract receives this call and it yields. On our platform, smart contracts can hold off, can wait. It's an asynchronous nature, so it's a little bit different than Ethereum, where the smart contract will spin up, run a routine, spin down, but it doesn't have to sit there and wait for all of the other promise chain to resolve before it spins back down. So you have to deal with some callbacks and stuff. We'll get into that another time, or feel free to ask me about it later. But yeah, the MPC contract will receive a call, wait for a response. Once it has the response from the MPC node is sitting there listening for it, captures the request, signs the transaction, and then it returns it. So now it can now be relayed out to whatever network it was. And to kind of go through it a little bit more, you have Anna here on the left-hand side wants to sign in a transaction on Ethereum. it asks to sign the transaction by calling a function call to this MPC contract right here. And meanwhile, the MPC service is actually listening for an event. And it says, oh, I just see that this event was called. Something was called to MPC contract.near. So what it does is it captures this request, and then there's a decentralized node service that reconstructs. It doesn't actually reconstruct the key at all, but it creates the signature. The key never actually even exists, so it's totally secure. These independent nodes sit there and verify and construct the signature and return the signature to the contract, takes that contract and it returns it back to the user. And then after that user has now this signed contract, they can relay it to Bitcoin, Ethereum, Solana, whatever network that you want to transact on. And we'll do a demo of this in just a second. But yeah, chain signatures, you don't need to manage keys across any platforms. You just have one that you log in and use. Basically one near account can nearly infinite amount of Ethereum accounts or any kind of EVM accounts you can control. One near account, almost infinite Bitcoin accounts, and so on and so forth. Solana, Doge, etc. Requests are made on chain. Any account can make requests, even smart contracts. So if you want to write a smart contract that then calls the MPC contract and do a bunch of cross-chain, cross-contract calls to create something cool, you're able to do that. So moment of truth. Let's do a live demo, see if this will work. And it should, but the live demo guides, you never know how they are going to treat me, and especially with the Wi-Fi. Okay, cool. So this is basically an application in the slides that I shared with you. There's a link to this repo, and in that repo on the upper right-hand side, there's a live website where this is live. So what I'm going to do is I'm going to log in with my wallet. I am going to use Meteor Wallet. I am going to connect. Cool. Now I'm in. And what it's doing is basically this address here is the address that it's deriving from. The step you're going to have to do here, and we should put in this example, is that you're going to need to fund your initial Ethereum address with some testnet ETH, which is a little bit harder to get these days. But yeah, get some testnet ETH, fund, once you log in here, you're going to have to fund your Ethereum account. And basically what this account is it's concatenating your user ID and whatever string you want to put in here. Like I could put Ethereum 3, or I could put Ethereum 2, or I could just put, let's say, ETH 2. Whatever you want, it'll create a unique address or a unique address for the Ethereum network that I can transact with. So right now I have Ethereum 1, which is my first account, and I do have it funded, with 0.09 ETH. Okay, cool. So I'm going to want to send it. Let's send it to another account, though, that I can actually control. So let's do Ethereum, let's say, because I was already messing around with this online. Let's just do ETH 2. And that'll give me this address, and you can see down here my balance is nothing. So we'll go ahead and I'll copy this address. I'm going to squeeze a little scratch pad over here. I'm going to take this. This will be my ETH 2 address. Cool. So now I can go back to 1. I'm going to grab this Ethereum address. I am going to paste it here. And then I'm going to send 0.001. Actually, just do 0.1 because, again, that testnet ETH is very valuable. 0.001 ETH. Okay, cool. We're going to request a signature. So now what it's doing is it's asking that question over. But before it does that, it's going to ask my wallet, hey, do I approve this transaction? I'm going to say, yep, I'm approving it. And then it's going to go through this chain of events. Right now, it's signing the transaction. Now it's sending it over to the multi-party contract. Now the nodes are waiting, hearing for this transaction. Awesome, cool. That's actually quicker than I thought it would be. Returns this transaction. Cool. Now we're ready to relay it. All right. Let's relay this transaction. The transaction has been reverted by the EVM. Oh, man. All right. Going to try one more time. The live demo gods. I swear this was working all night last night and all this morning and right before this event. Right before actually I stepped onto this stage, it was working. Oh, man. It always does this. I'm brought online live, and everyone's watching me in the audience sweat up here. Oh my God. All right. Again, it's requesting this transaction. We should also update this front end so that way it not only just relays the transaction, I'm sorry, not relays, it asks me to relay it again rather than trying to do it all over again. Oh, you know what? Actually, let's see if it's the amount of Ethereum that I added, because I feel like maybe I was being stingy with my ETH and it was getting cranky at me. All right, one more time. I swear this works. We're going to do it one more time. We got just a couple more minutes left. All right, we're going to prove it. Come on. You sign the transaction. At least the service is working where it's signing it. For some reason, the relayer is just unable to relay it. But if it doesn't work this time, we'll keep moving forward, and I swear it will work. And I'll show it to you guys after the cameras are off, and then it'll work. All right, so let's relay. It doesn't work. Okay, I swear this works. I swear it does. And sometimes it doesn't really, it just, that's how it happens. Anyway, I was going to show you multiple. Oh, I know. Wait a minute. Oh, duh. I don't have any ETH there. I did ETH1. Oh, it's me. User error. Was it Pepcac? Problem exists between keyboard and chair or something. I think it's me. It's an old IT joke. Oh, I don't think I had money there. I think this is all me. All right. Do we have my address? Okay, we do. All right. Let's just edit all this out on YouTube, please. Let's just pretend we didn't watch this. I know my brother's watching right now. He's like, I want to watch you on YouTube. I'm like, why are you doing that? You're making me nervous. He's watching right now, watching me sweat and fail. It was all my fault. I think the EVM was rejecting it because I didn't have any ETH in that address because I changed the string. Come on. Relay the transaction, please. Oh, it didn't reject me right away. We should have some better error handling. Hey, Bounty, if you wanna get some better error handling on my demo. Oh my God, I think it's gonna work. Yeah, see, and that was all me. Man, they're gonna fire me. Anyway, yay, successful. There, it worked, cool. So yeah, now we have 0.001 ETH on that Ethereum address. And yeah, we could keep it going. We could take that, and then that was going to be more of the demo, but I don't have time probably now, which would be, now I could take the Ethereum from that account and I could do, all right, let's do Ethereum 5. And yeah, if I did ETH, let's see, 2, I think that's where I sent it to, was it ETH 2? Yeah, cool, there's my balance right there. So yeah, anyway, it's pretty cool. You can just pretty much have an infinite amount of Ethereum addresses and transact using near one account to rule them all, kind of, and do a bunch of different things, which I think is pretty dope. All right, let's get back to the presentation, nice and safe over here in the slide land. My coworker did a GIF, and I did not do a GIF. I decided it's Ethereum global. You guys are all hacking. I should get up here and do things on the live. So I did it. Let's see. All right, we did access keys. We did this. We did a demo. Cool. Yeah, live demo. All right, it's back to the slideshow. So yeah, chain abstraction ideas. What could you do with this? Well, you could build a smart contract that triggers transactions in any EVM. I could build a DAO, like on Near, and then like proposals, or maybe something happens, it could trigger an action on Ethereum. You could buy an asset or change parameters on a contract. You could link cross-chain EVM accounts to an NFT. It could be sold on NFT marketplaces. You could group them all up. You could have one account that has access to a bunch of different NFTs and maybe sell that as a grouping. But yeah, you could build an app that creates link drops, drop assets on other EVM chains. I mean, there's really a lot of really awesome potential here that hasn't really even been tapped into yet. And I'm really excited to see what people like you guys are going to be doing for the hackathon and beyond. Cool. So that's that. We also have another bounty, like I said, with Near and AI. This is going to be yeah, basically what Near's trying to do with AI, again, we started in 2017 as AI, pivoted for 6 months, been a little bit longer, came back, now doing AI again. What does that mean? And basically the vision, and it's the same vision as it was with the protocol. It's we want to enable self-governance. We want to enable self-ownership. You own your data, you own your assets, you own everything. And we're seeing with AI, it's okay, I'm sending things to the cloud. Am I owning that? Where are they training that data on? Where is that stuff going? So yeah, it's a little concerning. And basically, yeah, we just want to own our own data, and we got some alpha that's going to be coming out pretty soon. But yeah, for you guys, not necessarily on what we're building, but we want to hear what you guys like. Take AI and Near and put it together. Build a project where Near is powered by AI, or build a project where AI is powered by Near. Either or. It's pretty much open-ended what you guys can think of. An autonomous agent, contract blockchain, think about smart contracts, make decisions on AI models. How could you combine Near and AI to create a decentralized finance? There's a demo here we can link to. I'm running out of time due to my demo, but again, these slides are available for you. Check out this demo. It's using GPT and a smart contract on our platform. All sorts of ideas that you could have for it. There's a showcase of AI projects being built on Near. Check it out on YouTube. Some developer resources, and then next steps for you. If you have no idea what you're doing, like me, just come and talk to me. We'll figure it out together. Here's all the resources you need. Scan that. It gives you the link tree. It'll give you docs, dev portal, online support. Come see us at the booth. I'm around hanging out. That's it. Thank you. Appreciate it. All right. Bye.